Corporate finance practice problem using Excel. Calculating the bond value with a bond that has semi-annual payments. Get ready, it's time to take your chance with corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, note that we are in the practice tab as opposed to the example tab. The example tab in essence being an answer key. We're going to have the information on the left-hand side. We'll populate that information into the blue area on the right-hand side. We're going to be calculating the value or price of the bond. This time, however, taking into consideration we have the semi-annual payments as opposed to annual payments, which will complex or make our calculations a bit more complex. Information, issuance of the bond, we're going to say the face amount is going to be the $1,500. Life is going to be 12%. The rate 12%. The life is 12 years. The rate is 12%. Semi-annual payments as opposed to annual payments. And then the market rate, what would not be basically on the bond but be determined by the market, is going to be the 14%. As we go through this calculation, due to it being semi-annual, we need to be careful about the life, which would be 12 years, but if we think of periods in terms of semi-annual or 6-month periods, which would be 12 times 2 or 24, and the rate, when we think about it in a yearly rate, which is typically what is given to us on the bond and the market rate, normally yearly rates because those are easier rates to give, because when you start giving monthly rates or semi-monthly rates, they start getting small. So you usually have the yearly rate, but if we break it down to a monthly rate, we would have to take those rates and divide them by 2. So we're going to do our calculation in a similar way as the past. We're going to have our annuity portion up top, which is going to be the annuity payments, and then the present value of basically the principal, the $1,500 at the end of the period, taking into consideration this time the semi-annualness of the payments. So first, the annuity calculation. We have P times 1 minus 1 plus R to the negative N over R. P is going to then be the payment of the $1,500 times the rate on the bond, 12%, divided by 2, since it's semi-annual payments. And then we have times 1 minus 1 plus R. The rate, now market rate, is going to be the 14%, but then divided by 2 to make it equivalent to the current 6-month period, or 7%, to the negative N, which would be 12 years, but now because it's semi-annual periods, there's going to have to be multiplied times 2, or 24, divided by R, also once again the market rate, the 14%, divided by 2. So let's do that here. We're going to break this out into our formula. We will then pick up the payment, which is going to be the $1,500, times the rate on the bond, which would be 12%. We would then divide it by 2. Before we do, however, let's look at that calculation. We would get the $180. Now we're going to take that would be for a year. That would be interest if we got the 12% in a year. Then we could then divide that by 2. I also just want to point out that you can think about this as taking the 12% divided by 2, which would give you the 6% rate per 6 months, and then multiplied by the 1,500. That's important because that's how you kind of think about it with the Excel functions, which we will see shortly. So I'm going to take this and divide it by 2. And then we're going to take the numerator, which is going to be 1, pulling this into the inside, 1 plus R to the negative N. So we're going to have 1, R. R then is going to be the market rate, 14%, divided by 2, or 7%. Number group, making that a percent. Font group, underlining it. Then summing this up with the trusty sum equals SUM, sum function of these two numbers. Making that a percent, going to the number group and making it a percent, 107. Then we're going to take this to the power of n, the negative n, the number of periods, which would be 12, but then we need to multiply it times 2 because it's for every 6 months. So the 12 times 2, negative 12 times 2, going to give us 24. Then we're going to go to the font group, underline, and pull this to the outer column. This is going to be the 107%, shift 6, caret, in other words, negative 24. Adding decimals here, home tab, number group, decimals. And then font group and underline, we could then subtract out the 1 minus that decimalized number to get the numerator. Adding decimals to it in the number group, adding a few decimals there. That's the numerator. The denominator also R, which is going to be the market rate, 14%, then divided by 2 because it's semi-annual. So we have the semi-annual rate. Number group, making that a percent. Font group, underlining it. Then we can take the num divided by the denom. So the num over divided by the denom, adding a few decimals there, number group, adding decimals to that one, then underline, font, and underline, multiplying out the outer column, this being the 90 times that number we just got to, adding a couple pennies or cents there, number group, adding a few pennies or a couple pennies, because there's only two when you're talking cents. That's going to be the 1,032.24. We will then have to present value the 1,500. But before we do, let's get to this one a couple different ways. Also, just realize that just intuitively, we would have the same kind of intuition here in terms of, do we have a premium or discount? If the rate on the bond is 12% and the market is 14%, and we were issuing the bond, we would think we're not going to be able to issue it at the 1,500 face amount here because other people can get similar bonds out there and get a 14% return. Therefore, we're going to have to issue it at some kind of discount. So it's going to be some amount that's going to be less than the 1,500 you would think, because the rate on the bond is less than the market rate issued then at a discount. Let's break this annuity down into present value of 1 payments, which is a little bit more tedious now because we're going to break it down to every 6-month time period. So I'm going to break this full annuity out into the number of payments 1 at a time, starting 1 and then 2, selecting those 2, grabbing Phil's handle for the autofill and dragging it on down. We're going all the way down here to 20 or 30 payments. We'll start at the 30 payments, which is actually, we need to start at 24 payments. We want 24 payments. Let's undo a couple of these. I'm going to unbluify some of these cells. We want the 24 payments there. Scrolling then back up top, we're going to pick up the payment, which is going to be 90 for every 6 months. Actually, I'll center this whole column too. Let's go ahead and just center that. So we got the 90, that's for every 6-month time period. And once again, we might want to calculate that. That would be the 1,500 times the 12% on the bond and then divided by 2. There's the 90. If I present value that, notice that the periods I'm looking at are 6-month periods. This would be negative present value, shift 9. Once again, negative present value, shift 9. The rate is going to be the market rate. That's going to be the 14% divided by 2, comma. The number of periods is going to be 1, that being a 6-month period, not representing a year. That represents 1 period or 6 months. And then we're going to say comma, comma for the future value, because this is not an annuity. It's going to be that 90. And that's going to give us 84. So 84, let's do it again. Payment will remain the same. Present value of period 2 or payment 2, which would be 1 year out, or the second 6-month payment. Present value, shift 9. Rate would be, let's pick up the 14% divided by 2 to emphasize that. That's that 7%. Number of periods, 2 now, which represents 1 year, 2 periods out, 6-month periods, comma, comma. Future value is the 90. If we then add those up, the 84 plus the 79, we have this. If we can add that on down then, making sure that we absolute reference what needs to be absolute referenced, anything outside the table typically, which would include that 14% in cell B9. So cell B9, put my cursor in that cell, select F4, putting a $sign before the B and 9, and enter. Then we can select these cells and put our cursor on the fill handle, dragging it on down to the 24 payments. That'll give us that 1,032, no pennies added here, matching our 1,032 here. We could tack on the last payment. We could tack on the last one here and say, what if I just add then also 24 periods out, but instead of that 90, we have the ending value of the 1,500, the par value or face amount that would be at maturity. Present valuing it in a similar way, 24 periods out would give us about 296. Adding that to the 1,032 gives us the answer, in essence, the 1,328, which would be the price. Let's go ahead and make that yellow. We're going to yellowify that one. And we'll get to that number again doing the present value calculation, the other standard ways that we've looked at. Let's do the annuity calculation here, getting to this number now the easy way, using the formula, noting that we have to pick up the proper numbers with regards to the semi-annual payments, so negative present value, this time the annuity formula. Rate is going to be then that 14 divided by 2, so the 14 divided by 2, comma. Number of periods now is going to be, years would be 12 times 2 for the 24, comma. And then the payment, because we are talking an annuity now, is going to be that $90, which could be calculated as the 1,500 times the amount on the bond, 12%, but then divided by 2, because we're talking semi-annual and that 12% is an annual rate. So that could be a little bit confused. Divided by 2, there we have it. So once again, here's the calculation. Looks a little bit confusing. It's good practice to kind of pull that over, do it a bunch of times, recognize what you need to do when you're talking semi-annual, recognize that you want to get the rate kind of lined up to the periods so that the calculation is proper. Also note that when you're looking at this in Excel, you're kind of picking up the yearly rate and then dividing it by whatever rate needs to be in place. So if it was like a monthly rate or something like that, it could be a very small rate, but Excel does it for us. So that yearly rate is fine. If it's a long decimal, small number, that's fine, because Excel, of course, will pick that up. But we're thinking about that in Excel for Excel to then pick up the rate equaling the periods. Periods then, in this case, being the yearly periods times 2, which would be the semi-annual or every 6-month periods. Okay, so that gives us that 1,032. The tables also area we have to be careful in. The amount that we would be looking at typically would then be the 1,005 times the 12% and then divided by 2. So the payment for 6 months would be that 90. And then if we want to present value it, making sure we have the proper table, present value of an annuity, we have the market rate down here, but not 14. That's for a year. Divided by 2, it would be 7. And then the number of periods is 12 years times 2 would be 24. So we're looking 7 and 24, 7, 24. We can see here in our calculation. So scrolling down, we're looking 7, 24, which is going to be 11.469, 11.469, 11.469, 11.469. If we multiply that out, let's just do the calculation. It's going to be 90 times 11.469 is going to give us the 103221. A little bit different than the 103224 due to the table's rounding to 4 digits. Now let's do the second component, present valuing the 1,500, the face amount or par value of the bond, the face amount of the bond. So we'll do our calculation here, present value of the future value, which would be, in this case, the 1,500 over 1 plus R, which is the market rate, which is going to be that 14%. I'm going to say divided by 2. So we have the periods in semi-annual, and then to the number of periods, which I'm going to use the 12% times 2 or 24. Let's go ahead and calculate that out. So we're going to say this is going to be the 1,500. And then we'll pick up the numerator, which is the denominator, which is 1. R is going to be this 14 market rate, but I'm going to take that and divide it by 2. And then go to the numbers group, make that a percent, underline it, font group, underline, and then sum this up equals the SUM of those two items. Make that a percent, number group percent, and then the number of periods I'm going to say is going to be equal to the 12 times 2 or 24 6-month periods. Then go to the font group and underline it. Then we got to take this up to the power of, so we're going to say this is going to be this 107% shift 6 caret to the power of, in other words, 24. Adding some pennies there or decimals. Adding decimals, underlining, font group and underline. Dividing out the num, 1005 divided by the denom, which is that thing we just got to. And then adding some cents, numbers, adding some cents there. There we have it. Now if we add that to the annuity that we just calculated, equals the annuity. I'm not going to pick it up from the tables, but from the Excel formula because it's more exact. We should then get to our price, the $295.72 plus the amount we got from the annuity, 1327.96. That should match 1327, what we got in the yellow box over here, 1328 without the pennies here. So that looks good. We calculated it again. This 1327.96. being less than the face amount due to the fact that the market rate is higher than the rate on the bond. Therefore, if we were to sell them, we would have to sell them basically at a discount. So let's go ahead and calculate this one a couple different ways. Let's do it with Excel now. Let's do it the easy way, the magic way, the Excel way. This equals the present value, shift 9, rate. I'm going to pick up the market rate again, 14%, but then divide it by 2, comma, number of periods, I'm going to say is the 12, and then times 2, 24, comma, and then comma, future value then being the 1,500. There we have it. Now this one let's move on to the tables here. We're going to go over to the tables and make sure that we pick up the proper amounts on the tables. We're going to say the amount's going to be that 1,500. Present value in it, making sure we got the right table. Present value of 1 this time. Rate is going to be the market rate, but that's the yearly rate. I'm going to divide it by 2 for the 7% for the rate per period, per 6 months. And then the life is 12 years times 24, because it's every 6 months. I'm sorry, times 2, which would be 24. So we're looking 7 and 24 on the table. So 7, 24. Here's the 7. 24 is down here. 24, 0.1971. 0.1971. So we're looking 0.1971. And then multiplying that out. And we get then to the 295.65, slightly different than the 295.72 due to rounding. So there we have it. Same kind of process to do the present valuation when we have these semi-annual payments or some payment other than annual payments. But you got to make sure that you're lining up your rates and your number of periods properly and picking up the proper tables if you're using the tables, and making sure you got the right percent and numbers down here on the table for periods, and noting that the tables do not represent years or anything like that, or the percent per year. They just got to make sure that you're lining those things up. No matter what method you use, you're going to have to basically do that, making sure that you're lining up the proper percent and the proper period